Autumn 1943. The captured American submarine, now a silent trophy in Italian hands, yielded its secrets slowly. Amidst the advanced machinery, the complex navigation systems, and the classified documents, a seemingly ordinary pencil lay forgotten on a chart table, a mundane artifact amidst the marvels of wartime engineering. Yet, when Italian engineers, with their meticulous attention to detail, tested its graphite, they uncovered a property so unexpected, so vital, it hinted at a silent, almost invisible advantage in the war's hidden depths. This small, unassuming object, a simple writing tool, would challenge their understanding of enemy ingenuity and the subtle ways in which technological superiority could manifest. To understand how this seemingly minor discovery held such significance, we must first delve into the relentless naval warfare that defined much of World War II. The vast, unforgiving oceans became sprawling battlegrounds where submarines, surface fleets, and aircraft vied for supremacy in a deadly high-stakes game of cat and mouse. Submarines, in particular, were the silent hunters, operating in a world of perpetual twilight, their missions often stretching for weeks or even months beneath the waves. In these cramped, often damp, and perpetually humid environments, communication and accurate record-keeping were not merely administrative tasks. They were paramount to survival and mission success. Every piece of equipment, from the most complex torpedo guidance system to the simplest writing implement, had to be utterly reliable and functional under the most extreme conditions. The Axis and Allied powers were locked in a constant, desperate struggle for technological advantage, pouring immense resources into developing new weapons, advanced detection systems, and even the most mundane tools that could offer the slightest edge. From the sophisticated hydrophones designed to detect enemy vessels to the intricate mechanisms of depth charges, innovation was not just a goal, it was a matter of life and death, a continuous race against the enemy's capabilities. The ability to quickly and accurately record observations, to transcribe critical orders, or to document damage reports during an emergency could mean the difference between a successful patrol and a catastrophic failure. Imagine a submarine commander needing to plot a new course under fire, or a sonar operator needing to log a fleeting contact, only to find their writing tools rendered useless by condensation or a sudden leak. This relentless pursuit of superiority extended to every conceivable aspect of military operations, no matter how small or seemingly insignificant. The cumulative effect of countless small efficiencies and reliable tools could, and often did, tip the balance in critical moments. The psychological impact of knowing one's equipment would perform flawlessly, even in the most adverse circumstances, was also a powerful, if intangible, asset. It was within this context of total war, where every detail mattered, that the American pencil would make its unexpected debut on the stage of intelligence analysis. The sheer scale of the conflict demanded perfection from every component, and the engineers on both sides understood this implicitly, pushing the boundaries of what was thought possible in material science and design. The specific situation that brought this pencil to the attention of Italian engineers unfolded in the aftermath of a successful Axis naval operation, a moment of triumph that often masked the underlying desperation of the war. While the exact circumstances of the American submarine's capture remain shrouded in the fog of war, perhaps disabled by depth charges, forced to surface, or caught unawares, its acquisition was a prize of immense intelligence value. Such captures were rare and highly sought after, offering invaluable first-hand insights into enemy technology, tactics, and operational capabilities that no spy report or aerial reconnaissance could provide. Once secured, the vessel would have been meticulously searched by specialized teams, a painstaking process that transformed the enemy's war machine into a laboratory for reverse engineering. Every compartment, every locker, every piece of equipment, no matter how small or seemingly innocuous, was scrutinized with an almost forensic intensity. Documents, maps, codebooks, personal effects, and even the most common tools were collected and sent for analysis to various intelligence branches and scientific laboratories. This process was painstakingly thorough, often taking weeks or even months as experts from diverse fields, naval architects, metallurgists, Electronics specialists and material scientists worked tirelessly to piece together the complex puzzle of enemy design and operational procedures. The submarine itself, a marvel of engineering, was a treasure trove of information, from its advanced propulsion systems and intricate ballast tanks to its internal layout and crew amenities. In the humid, salt-laden air of the captured vessel, amidst the complex machinery, the lingering scent of its former crew, and the quiet hum of its now silent systems, the search for intelligence was relentless and all-encompassing. It was in this environment of intense scrutiny, where every rivet and every dial was examined, that the seemingly insignificant pencil was discovered, a small detail, easily overlooked by the untrained eye, yet destined for an unexpected revelation that would highlight a subtle but critical difference in wartime innovation. The very act of its discovery, amidst the grandeur of a captured warship, underscored the principle that in total war, nothing was truly insignificant. The protagonists in this particular understated chapter of wartime discovery were not the heroic pilots who soared through the skies or the daring commandos who executed audacious raids. Instead, they were a dedicated team of Italian naval engineers and intelligence analysts, men whose battles were fought in the quiet confines of laboratories and workshops rather than on the tumultuous front lines. These individuals, often the unsung heroes of the war effort, worked tirelessly behind the scenes, their contributions vital, yet rarely celebrated in public. They were experts in their respective fields, possessing a deep and nuanced understanding of metallurgy, mechanical engineering, and material science, disciplines that were critical to both developing their own armaments and dissecting those of the enemy. Operating under immense pressure, with the fate of their nation hanging in the balance, they were tasked with the unenviable job of dissecting enemy technology, identifying its weaknesses, and, crucially, replicating its strengths. Their work was indispensable to the Axis war effort, providing vital intelligence that could inform strategic decisions, improve their own military hardware, and counter Allied advancements. They approached their tasks with a methodical precision, a scientific rigor born of necessity, driven by a profound sense of duty and the stark knowledge that their findings could directly influence the course of the war. Their collective expertise allowed them to discern the subtle nuances of foreign engineering, to recognize the potential significance of an unusual component, or to understand the far-reaching implications of a novel design, even when it appeared in the most unassuming form. It was this collective intellect, combined with an unwavering, meticulous attention to detail, that would ultimately lead them to the surprising properties of an ordinary American writing instrument. They were trained to see beyond the obvious, to question every assumption, and to understand that sometimes the greatest innovations lay hidden in plain sight, disguised as the mundane. Their work was a testament to the fact that the war was not just a clash of armies, but also a relentless competition of minds, where every scientific breakthrough, no matter how small, could contribute to the larger strategic picture. Chapter 2. Protagonist. The American pencil, a seemingly humble instrument, carried a lineage stretching back centuries, its evolution a quiet testament to human ingenuity and the persistent need for effective communication. The fundamental concept of encasing a graphite core in wood for writing emerged in the 16th century, evolving from crude, lead-filled sticks to the highly refined and mass-produced tools of the modern industrial era. By the early 20th century, pencil manufacturing had become a sophisticated industry, with companies across the globe, and particularly in the United States, constantly seeking improvements in graphite quality, lead hardness, and overall durability. American manufacturers like Dixon Ticonderoga and Eberhard Faber had perfected their craft, producing millions of pencils annually for a vast array of purposes, for schools, offices, artists, and increasingly, for the burgeoning military. These companies invested heavily in research and development, not just for marketing advantages, but to meet the diverse and often demanding needs of their clientele. The quality of the wood, the consistency of the graphite, and the ergonomic design were all subjects of continuous refinement. For naval applications, however, the challenges were uniquely formidable and often overlooked by general manufacturing standards. Standard pencils, while perfectly effective on dry paper in a stable environment, became utterly useless when exposed to moisture. The paper would quickly tear and disintegrate, the graphite would smudge into an illegible mess, and any marks made would be ephemeral at best or completely impossible to create at worst. This was a significant and persistent problem for sailors, particularly those serving in submarines, who needed to record vital data, draw precise charts, or jot down critical observations in environments perpetually prone to high humidity, pervasive condensation, and even direct water exposure from leaks or spray. The need for a reliable writing instrument that could function effectively and consistently under such adverse conditions was acutely felt throughout the naval forces, driving a quiet, often unacknowledged, area of material science research and development. It was a problem that, while not as glamorous as developing a new weapon, was equally critical to operational efficiency and safety. Before the advent of this particular American innovation, naval personnel, both Allied and Axis, relied on a variety of makeshift or specialized tools for writing in wet conditions, each with its own set of significant drawbacks. Wax pencils, similar in composition and function to crayons, could indeed make marks on damp surfaces, but they were notoriously imprecise, prone to smudging, and often left thick, difficult-to-read lines. Their marks lacked the clarity and detail required for critical logs or intricate chart plotting. Slate tablets and chalk offered another option, providing the advantage of reusability, but they lacked the permanence and fine detail necessary for official records or complex diagrams. The chalk could easily rub off, and the slate itself was bulky and fragile. Specialized waterproof paper, often coated or impregnated with resins to repel water, also existed, but it was typically expensive to produce, bulky to store, and not always readily available in the quantities needed for widespread military use. Furthermore, even waterproof paper could be damaged, and finding a suitable writing implement for it remained a challenge. These existing methods were cumbersome, inefficient, and far from ideal, especially in the fast-paced, high-stress and often chaotic environment of wartime operations. Imagine a submarine commander, deep beneath the surface, needing to quickly sketch a tactical maneuver during an enemy encounter, or a damage control officer, needing to record vital readings from a compromised compartment during an emergency. In such moments, the failure of a basic tool like a pencil due to dampness or water could lead to critical delays, miscommunications, or even catastrophic errors. The frustration among crews was palpable, and the limitations posed by inadequate writing tools represented a genuine, if often unaddressed, operational hurdle. Every second counted in these life-or-death situations, and the inability to record information efficiently and reliably could have dire consequences, highlighting a persistent yet largely unglamorous gap in military equipment that demanded an innovative solution. The cumulative effect of these small frustrations and inefficiencies could, over time, impact morale and operational effectiveness. The seemingly insignificant discovery of the American pencil in the captured submarine thus represented a subtle but profoundly important technological advantage. It was not a weapon that fired bullets or launched torpedoes, but a tool that enhanced the efficiency and reliability of those who operated such weapons. It stood as a quiet testament to the continuous, often unseen efforts of Allied engineers and manufacturers to solve even the most minor logistical problems, recognizing that every detail contributed to the larger war effort. The Italian engineers, accustomed to the inherent limitations of their own writing implements in wet conditions, would soon confront a simple object that defied their established expectations and revealed a superior approach to material science. This small wooden cylinder, with its unassuming graphite core, was about to reveal a secret that spoke volumes about the ingenuity, foresight, and comprehensive approach embedded within the enemy's industrial base. It was a stark reminder that victory in modern warfare was not solely determined by the size of armies or the destructive power of weapons, but also by the cumulative effect of countless small innovations, each meticulously designed to make operations more efficient, more reliable, and ultimately more effective. The stage was set for a moment of quiet revelation where a common object would unveil an uncommon capability, forcing a re-evaluation of what was possible and highlighting the depth of the technological competition. This pencil was more than just a writing tool. It was a symbol of a deeper commitment to operational excellence, a commitment that extended to every piece of equipment, no matter how small. The very existence of such a specialized tool indicated a proactive approach to problem-solving that the Italian engineers would soon recognize and, in turn, strive to emulate. It was a subtle psychological blow, a realization that the enemy was thinking about problems they had not yet fully addressed. The implications of this small discovery would resonate far beyond the laboratory, influencing future research and development efforts within the Italian naval forces. The simple act of writing, often taken for granted, was revealed as a critical component of wartime efficiency, and the American pencil had mastered it in an environment where others failed. Chapter 3: Challenge and Action. The Italian engineers, having meticulously catalogued and scrutinized every item recovered from the captured American submarine, approached the mundane pencil with a degree of professional skepticism tempered by an underlying curiosity. It looked, by all appearances, like any other graphite pencil, a cylindrical piece of wood encasing a dark core. Yet the very context of its discovery, aboard an enemy vessel renowned for its advanced design and operational sophistication, suggested that nothing should be dismissed out of hand. In the high-stakes world of wartime intelligence, even the most trivial object could harbor a hidden secret or reveal a subtle advantage. Their dilemma was not whether the pencil was a weapon in the conventional sense, but rather if it possessed any hidden properties that could offer insight into American material science, manufacturing capabilities, or operational practices. Was this simple writing tool merely an oversight, a forgotten item? Or did it, like so many other components on the submarine, hold a secret, a deliberate design choice that conferred an advantage? Standard procedure dictated that every single component, no matter how trivial its appearance, be subjected to a battery of tests designed to uncover its purpose, composition, and performance characteristics. The engineers, led by Dr. Emilio Rossi, a seasoned expert in naval materials with a reputation for meticulousness and an almost intuitive understanding of engineering principles, decided to test its most basic function under the conditions most relevant to its origin, underwater. Dr. Rossi, a man in his late 40s with sharp analytical eyes and hands calloused from years of working with machinery, understood that the most profound innovations often lay hidden in plain sight. He had seen countless examples of enemy ingenuity, from subtle improvements in propeller design to novel approaches in hull construction. He knew that the true measure of a nation's industrial might lay not just in its grand projects, but in its ability to perfect the smallest details. The question was not just if it could write, but how it performed compared to their own best efforts, and what that implied about the enemy's comprehensive capabilities. The decision to test the pencil in water was made during a routine intelligence briefing, a moment of quiet contemplation, amidst the usual flurry of reports and analyses. Dr. Rossi, holding the pencil between his fingers, turned it over, examining its slightly faded yellow paint and the subtle texture of its wood. He remarked on its robust construction, noting the apparent quality of the wood and the dense, dark appearance of the graphite core. "It's just a pencil," one junior officer, Lieutenant Marco Bianchi, commented, a hint of dismissiveness in his voice. But everything else on that boat was designed for a specific, often advanced, purpose. "Why this?" Rossi nodded slowly, a thoughtful, almost pensive expression on his face. "Precisely, Lieutenant. Let's see if it truly is just a pencil." His words carried a quiet authority that silenced any further skepticism. He then instructed his team to prepare a small basin of seawater, carefully collected, to replicate the exact salinity and temperature conditions found within a submarine's interior, where condensation and leaks were a constant threat. The atmosphere in the laboratory was one of quiet anticipation, a unique blend of scientific curiosity and professional duty. This was not a test of a new engine, a complex communication device, or a revolutionary weapon system. It was a test of something so fundamental, so seemingly trivial, that its potential significance was almost overlooked by all but the most discerning minds. Yet the meticulous nature of wartime intelligence meant that no stone could be left unturned, no detail too small to investigate. The engineers, dressed in their crisp white coats, gathered around the test station, their faces illuminated by the harsh overhead lights, ready to observe a simple experiment that might, just might, yield unexpected and insightful results. Their collective experience had taught them that sometimes the most profound discoveries came from the most unassuming sources. The air was thick with the scent of ozone and salt, a constant reminder of the naval environment they sought to understand and master. With the basin carefully filled with seawater, Dr. Rossi proceeded with the experiment. He first submerged a piece of standard naval chart paper, allowing it to become thoroughly saturated, its fibers absorbing the water until it was limp and glistening. He then took the American pencil, its yellow paint slightly worn from use, and dipped its sharpened tip into the water, ensuring it was fully wet. A hush fell over the room, the only sound the gentle lapping of water in the basin. With a steady, deliberate hand, he pressed the pencil against the wet paper. To the astonishment of everyone present, a clear, dark line immediately appeared. He wrote a few words, perhaps a date, a ship's name, or a simple observation. Then a series of numbers, each mark distinct, legible, and remarkably crisp, without any hint of smudging or tearing the delicate, waterlogged paper. The graphite, instead of dissolving or becoming ineffective as expected, seemed to adhere perfectly to the wet fibers, leaving an indelible trace that defied conventional understanding. Dr. Rossi then attempted to erase the marks with his thumb, but they remained firm, unyielding to the pressure. The graphite seemed to have bonded with the paper in a way that resisted smudging even when wet. He then repeated the test with a standard Italian naval pencil, a high-quality instrument by their own standards. The contrast was stark and immediate. The Italian pencil's graphite crumbled and dissolved upon contact with the wet paper, creating a faint, smudged mess, and the paper itself began to tear under the slightest pressure. The difference in performance was undeniable, almost shocking in its clarity. The American pencil was not merely functional underwater, it was remarkably effective, performing as if it were writing on a dry surface. This was a testament to an unseen innovation, a subtle but critical advancement in graphite composition or bonding that had eluded their own material scientists. The implications of this small yet profound demonstration began to dawn on the assembled engineers, revealing a gap in their own technological capabilities. The immediate result was a mixture of awe, professional admiration, and a touch of humbling realization. The Italian engineers, initially skeptical of any grand revelation from such a simple object, now understood that they held in their hands a small but potent piece of enemy ingenuity. This seemingly insignificant pencil was a clear and undeniable demonstration of a superior material science capability, a subtle advantage that could have far-reaching impacts on naval operations, particularly in the clandestine world of submarine warfare. It was not a weapon of mass destruction, nor a revolutionary propulsion system, but a fundamental tool that enhanced efficiency, reliability, and accuracy in the most challenging and unforgiving environments. The ability to reliably record information underwater meant less ambiguity, fewer errors, and faster decision-making for American crews. This small victory in material science highlighted a broader, more comprehensive approach to military equipment design that extended to every detail, no matter how small. Chapter 4: Consequences and Legacy. The discovery of the underwater writing pencil sent ripples of intrigue and concern throughout the Italian naval intelligence community. While not a game-changer in the same dramatic vein as a new radar system or a more powerful engine, it represented a significant, if subtle, technological gap that could have tangible operational consequences. Dr. Rossi's team immediately set about the painstaking process of dissecting the pencil, not just physically, but chemically. They meticulously analyzed the graphite's composition, its binding agents, and its unique interaction with water at a molecular level. Their initial hypotheses centered on two main possibilities. Either the American manufacturers had developed a unique blend of graphite and clay that possessed an inherent resistance to water absorption, or they had ingeniously incorporated a hydrophobic polymer directly into the lead itself, creating a barrier against moisture. This required advanced chemical analysis, a process that was both time-consuming and resource-intensive, but deemed absolutely necessary. The implications of this seemingly minor innovation were clear and concerning. American submarine crews and potentially other naval units operating in damp conditions possessed a reliable and efficient means of recording critical information in environments where their Axis counterparts struggled with smudged notes and disintegrating paper. This translated directly into faster, more accurate data logging, improved internal communication, and a significantly reduced risk of errors stemming from illegible or lost information. Imagine the advantage of a submarine commander being able to precisely plot a new course or record a vital observation during a sudden downpour or a minor leak, while his enemy was fumbling with unreliable tools. The Italian High Command, upon receiving Dr. Rossi's detailed report, recognized the strategic value of this small but potent advantage. They initiated an urgent, high-priority project to replicate the technology, understanding that even seemingly minor operational efficiencies, when accumulated across an entire fleet and over prolonged periods, could translate into a substantial strategic advantage over time. The challenge was not just to understand what the Americans had done, but how they had achieved it, a task that would require considerable research, development, and a deep dive into material science. The historical impact of such seemingly minor innovations often goes unnoticed, overshadowed by the grand narratives of battles, political maneuvering, and the development of large-scale weaponry. Yet the story of the underwater writing pencil serves as a powerful testament to how victory in World War II was also, in large part, a triumph of relentless problem-solving and the continuous pursuit of practical solutions to everyday operational challenges. It underscored the critical importance of industrial capacity and scientific research, not just for building tanks, aircraft, and battleships, but for perfecting the myriad of tools and equipment that supported the fighting men and women on every front. The psychological effect on the Italian engineers, realizing that the enemy possessed such a simple yet profoundly effective tool, would have been significant. It suggested a level of thoroughness, ingenuity, and attention to detail that extended to every aspect of the American war effort, fostering a sense of respect and perhaps even a touch of apprehension for the depth and breadth of Allied innovation. This small pencil, unassuming in its appearance, became a quiet symbol of the hidden battles fought in laboratories, workshops, and factories, far from the roar of cannons and the flash of explosions. In these unseen arenas, scientists and engineers contributed to the war effort by making life easier, safer, and more efficient for those on the front lines. It was a stark reminder that the war was won not just by grand strategies and heroic acts, but by countless small advantages, each meticulously developed and deployed. These incremental improvements, when combined, created a cumulative effect that could, and often did, tip the balance in favor of the side that embraced them most effectively. The pencil was a microcosm of the larger technological race, demonstrating that even the most basic human needs, like the ability to write, were subject to wartime innovation. It highlighted the comprehensive nature of modern warfare, where every detail, no matter how small, could contribute to the overall strategic picture. After the war concluded, the technology behind waterproof writing instruments, once a closely guarded military secret, became more widely known and accessible. The specific composition and manufacturing techniques of the American pencil's graphite likely contributed significantly to the broader understanding of material science, influencing the development of various specialized writing tools for both military and civilian applications. While the immediate military urgency subsided with the cessation of hostilities, the fundamental need for reliable writing in wet conditions persisted across numerous sectors. The ingenuity that went into that wartime pencil found new life and purpose in countless civilian products, from the robust pencils used by divers and underwater explorers to the specialized pens and notebooks favored by construction workers, outdoor enthusiasts, and even artists seeking new mediums. The engineers and scientists who toiled in wartime labs, whether Allied or Axis, laid much of the groundwork for many of the technological conveniences we take for granted today. Their dedication to solving problems, no matter how small or complex, left an enduring legacy of innovation that continued to shape the world long after the last shot was fired, proving that the pursuit of efficiency and reliability is a timeless endeavor. This is the true legacy of the unassuming American pencil. It stands as compelling proof that even in the most brutal and destructive conflicts, human ingenuity thrives in the most unexpected places, often in the quiet pursuit of solving seemingly minor problems. It reminds us that war is fought not only with grand machines and sweeping strategic maneuvers, but also with clever, often overlooked solutions to the everyday challenges faced by those on the front lines. The human spirit, when challenged by adversity and driven by necessity, possesses an extraordinary capacity to transform the simplest object into a powerful tool, capable of influencing the course of history in ways both seen and unseen. This small, humble pencil, discovered in the depths of a captured submarine, serves as a powerful testament to the fact that innovation, in all its forms, is a continuous and vital force, shaping not just the outcomes of conflicts, but the very fabric of our technological world.